UDC.
My name is Mark Nordheim, and I am with Ameren, and we're going to talk about how we have been implementing utility network. So we're going to go over who we are real quick and why we're doing utility network, and I'm going to also go over some of the challenges we faced at the beginning and what we did to mitigate them, and then I'm going to hand over the presentation to our partners from UDC to talk about some of the technical details of what they did, and then I'll close it up with talking about how things ended up and where we are now. So again, I am a senior software engineer at Ameren. I've been working on Ameren's transmission GIS for almost 10 years now, and I've been a GIS developer for longer than that. Jacob is a developer at UDC who has been responsible on this project for basically converting our web viewers and various scripts and apps that we have developed on our old GIS model over to work with our new utility network model. And then Jimmy Taylor is a GIS analyst at UDC, and he has focused on data modeling in building out our utility network data model and doing the data conversion and migration process. So who are we at Ameren? We are a fairly large utility in the Midwest. We are based out of St. Louis, and our territory covers a lot of Illinois and a fair amount of Missouri as well. We provide electric distribution service to most of that territory, gas distribution service in quite a bit of Illinois and parts of Missouri, and then we have electric transmission throughout the territory, with over 7,000 miles of transmission. We also do generation in Missouri, but I am focused on electric transmission in my role. The other services have their own GIS people, which some of whom are in the room, but no. So why did we go to utility network? Well, we had a fairly outdated data model that had no network capabilities at all. It was points and lines, which I think a lot of transmission GIS operators would be familiar with. That we just have our transmission structures and the spans between them, and we wanted to move on to a modern networked model. We thought that it would help us with data quality because of all the rules and topology checks that are involved. But the main challenge we faced is that there aren't a lot of electric transmission customers that have moved to the utility network yet. If you've been to presentations like this before, they probably focus mostly on electric distribution, gas or water. Electric transmission, there's been very few companies that have completed the transition. So there wasn't a lot of examples to go by, and so we really had to work to make sure that our data could fit into an utility network data model in the correct way. So the project goals were, again, to ensure data quality, and that is by making sure we have good rules in place for all of our relationships within the data and our network model, so that there would be topology checks and validation when editing, which we'd never had as well developed at their old, less networked model, and then also to just be on the current standard for going ahead, for being able to implement all sorts of new features going forward, using network traces to answer questions we couldn't answer before, and being ready to expand in various ways like that. And then Another very specific business driver, which I am sure that a lot of other companies have, is that we have network, is that our transmission department at Ameren has network models and a lot of different software that don't really talk to each other. And so, we have our EMS model, we have PSSE for planning, we have Aspen for system protection, and then we have a house internal model called TROPS, which is used for a lot of short-term planning and operations and things like that, and for ratings. So we have this concept called the Network Model Manager for bringing all those things together and getting our GIS model into a SIM-compliant format that has room for all the different data fields that are in these other models was a sort of prerequisite for allowing our system to participate in this network model management framework. A couple of the other problems we faced, and one of them was that we had a lot of pieces in our pre-existing data model, like dampers and cross arms and stuff that weren't really very well implemented in the base utility network model that existed before us. So I'm going to pass it over to Jimmy now, and he can talk about implementation.
So yeah, real quick, with utility network, I just wanted to mention that it can be quite a lot, and this is a relatively short session. So if you guys have any questions on anything, I'll be around after. We have some other folks here that are highly qualified. And you can feel free to stop by the UDC booth if there's anything you just want to ask about. But yeah, I just wanted to give an overall walkthrough of our UN implementation approach. And this really starts with a robust analysis of the existing GIS. It involves sitting down with our partners at Ameren and really learning their system from the folks that know it the best. And then starting to identify those potential utility network targets for their data. The next phase would be where we're actually mapping the GIS schema into an electric utility network model. And to do that, we make use of a custom tool that we call HIDE at UDC, which is really fundamental in the process. It allows us to combine the GIS source data with a utility network template to create an output asset package. And then along the way, our tool provides data validation as we're migrating the schema, attributes, domains, so that saves us time down the line, and we got to do a lot less rework when we're in the utility network. And then along the way, there's a lot of configuration that happens and some settings that get tweaked in the asset package stages and beyond, setting the system tables in the asset package, setting up utility network rules, our subnetwork configurations, and our trace configurations. And this whole process really happens through multiple iterations. Mark's and Ameren has been great in doing some data cleanup along the way, but we're doing this over and over and learning a lot along the way. The next, with a new electric UN model implemented, it really needs to be any of the existing systems that Ameren has in place, their FME workbenches, their nightly scripts, need to be integrated in that model, and I'm going to hand that over to Jacob in just a couple minutes to go into some more detail. But we're targeting our full electric transmission utility network go live for just a little bit later this summer. And a couple things to mention. Again, we don't have tons of time to go into detail, but UDC has a suite of custom tools. If you guys have questions about any of what's in that toolkit, please stop by the booth 519 later today. But a couple items I wanted to mention in our implementation. So what Mark mentioned is it's a lot of points and lines, and we didn't have a lot of devices. They don't have internal substation equipment mapped yet. I believe that's scheduled for a future phase, hopefully, to map the internal substation elements. But so what we didn't have is something that we would target as a subnetwork controller device for our subnetwork controllers. So what we did here, the desire was to have full transmission lines be individual subnetworks. And we did have structure data within, they actually have really good structure data and really good placement. We took the last structure that was present internal to the substation, and we actually migrated that in as an electric device, which we were able to set as our subnetwork controller. And another thing that I'll visualize a little better on the next slide is how we used associations. I mentioned substations are just point data. We didn't have the internals, so we actually brought those in twice. Once as a structure junction, and then again as an electric device, which sounds kind of strange, but what that allowed us to do is, for a lot of transmission lines, they flow through substations, and we were able to use associations, junction-junction associations, for those that are familiar, to connect and trace through substations, which I'll show on this next slide. So here you get a bit more of a visual. This is just kind of a zoom-in overview of a substation. On the left side, this is what the GIS looked like in advance. This is a substation, and remember, there's no geometric network. And what might be difficult to see is we've got a lot of stacked conductors. So if you look in the top left, you just see that's another line running by the sub. But if you look on the updated utility network side, something we do along the way with one of our tools is we actually offset those conductor spans while retaining the connectivity between them, so it allowed us to then do full UN tracing. But notice that we've got shield spans and conductor spans now offset from the structure. And the other thing that happened, I guess I can just walk over it pretty tall. Notice those are only structures inside the substation. There's bus structures, arbor structures. They didn't really need this long term because they're going to be modeling substation internals in the future. But what we were able to do is these arbor structures were really the last structure exiting the substation. We brought these in as electric devices, and then many of those we could set as our sub-network controllers. And really, a screenshot of electric transmission really doesn't tell the full story. It's long distances of spans, a lot of points and lines. But with utility network, so you can't really visualize everything that it does in a picture. But with utility network, it's really about what it does behind the scenes. And so if you consider where we started, no geometric network, a lot of stacked spans, and where we ended up, it's a big step forward to go from no geometric network to a full utility network. And I just wanted to say that really we were only able to be successful on this project because of the folks we've been working with and the teamwork and the collaborative approach. And I'll emphasize both of those words on the slide. It's collaborative and it's a process. The collaboration, Ameren's been able, this is multiple iterations. We come back with spreadsheets of items for them to clean up in the data cleanup phases. They turn those around and get those in for our next iteration. So they've been great, but also our partners at Esri very early on in this project. There really weren't a lot of some of the items that Mark mentioned, the dampers on the line splices, a lot of different elements of non-spatial objects that are typically like related child records of the spans and the structures as well, your anchors or whatever else. And early on, we met with Esri, discussed some of these items, and they very quickly turned around a beta release that we were able to use, and they did that multiple times for us. So thanks to our partners at Esri. It was only working together that we were able to be successful. And so we're really hoping, I mentioned the word process. I know a lot of folks might be new to utility network, and it can feel like quite a process. But don't be scared. It's definitely worthwhile. New users might feel overwhelmed even by like terminology, a lot of new words. You get used to it, and if there's also always some internal utility, resistance. Some folks don't want to make the big change. But what a lot of new users don't realize, what I didn't realize in advance, was you can really customize the model to your needs. You don't need to use the whole thing. You can rename items if you need to. So there's a lot of customization that can be done, and it can make you a lot more comfortable. And so we're really hoping that Mark mentioned not having many examples of electric transmission in utility networks. So we're really hoping that some of the work we've done on this project can be used by other utilities and help pave the way for other projects. But I'll turn it over to Jacob for a little more detail on some of the integrations that we had to do with the Ameren systems. Jacob.
As Mark and Jimmy already mentioned, migrating to a utility network is going to have a downstream effect on other processes. So that's where I stepped in to perform some of those updates on, I guess, 3 categories: FME workbenches, Python scripts, and web apps, to make sure that they reflected the UN and that we were utilizing the UN to its full capability. With workbenches, we integrated with OPPN for project management and Maximo for asset management. And then for Python, Ameren has a script that runs nightly, and the goal of that script is to identify inconsistencies in their transmission data and update things accordingly. And part of how it does that, we'll come back to this, is part of how Ameren does that is by relating different features from different feature classes, which becomes important later. The general steps involved in these different processes remained the same, right? Most of these are basic ETL, extract, transform, load. But we did update a few things. I listed 2. One was data extraction, right? So it's what we were able to do is utilize some of the functions, built-in functions in FME and in ArcGIS Python to make a request to the UN service to extract the proper data needed for the workbenches and for the script. We also worked a little bit with how the different features from those different feature classes were related to one another. So originally, most of these relationships between features were handled based off of geometric coincidence. And with utility network, we were able to relate features from different feature classes with associations. We were able to do this in certain cases. There are certain restrictions with the utility network as to which feature classes can be associated with other ones. But where we were able to create those associations, we were able to use those instead of geometric coincidence. The third process that was updated to integrate with the UN was Ameren's electric transmission viewer. Now, as sort of a side mission to this overall UN migration project, Ameren also decided to upgrade from Web App Builder to Experience Builder. And they had a few reasons for that, but one of the reasons was so that they could utilize the built-in Experience Builder functionality to work with the utility network. I listed an example here with the utility network trace widget, which is out of the box Experience Builder. We'll see that in a second. And then we were also able to develop a widget in Experience Builder that, again, we'll see in just a second, called the UN search widget. Starting with the utility network trace widget, which you can find in Experience Builder. Simple, you're able to perform traces based off of the trace configurations of your utility network. So the example here is performing a trace on an electric line, a sub-network trace. And then the widget that we developed is called the UN search widget. And the idea with this, if I can simplify, is so you're able to search a field on a feature class within the UN, and then it takes all the features with that field value, traverses the various associations, and spits out the related features on a different feature class. So in this example, you're searching a line name on a feature class, and it's going through the UN associations and spitting out all the related structures based off of that search. And with that, I'm going to hand it back to Mark.
All right, thank you, Jacob. So I think the project has been a big success, and a big reason for that is that we had such a great partner in UDC. I mean, I've been researching the utility network for years before we brought them in, and I think that is also an important thing, is that I really understood what by the time we brought UDC in, I already understood the basics of utility network and what the steps would have to be to migrate to it, and where our deficiencies were, and sort of what the pain points would be in doing this, so we could sort of get started. Once we brought them in, we were able to get started right away on solving those issues and working through them. And like Jimmy said, working with Esri to get changes to the base model to support some of the things we needed to do that hadn't been done. But some of the benefits we're getting out of this project already is that our overall GIS infrastructure has never been in a better place. Like we have best practices on hardware and software deployments now. We're using the newest versions of everything Esri has put out. We're using Enterprise 11.1, Pro 3.1. We're using Experience Builder for our web apps. So it's all on the JavaScript 4x standard. Our system architecture was based on an architecture review that Esri did for us. And we are, as I mentioned before, we're looking forward to the editing process in our network being more structured and easier to validate and check. We have better security on our system as a result of this, because we were able to implement different authentication processes, and again, scalability and data quality are other benefits. Like we are ready moving forward to do more things with our GS data than we ever have before, because we have this network data set that's extensible, it has room in it for other things. So let's get into a little bit more detail on that. I'm going to try to wrap up pretty quick to leave some time for questions here, but we are, I believe, less than a month from our go live date now. So this project, because of all the preparation, like this project went pretty fast. I think I think the time from our kickoff with UDC to go live is going to end up having been about 10 months. So again, we've been looking into things for years before that, but the actual work of the project went pretty quick once we figured things out and got started. So we are looking to do a phase 2 of this project, and that is getting the internals within a substation into our GIS. Because right now, again, like Jimmy mentioned, a substation in our data is just a point, but we really want to model the switches, the circuit breakers, the transformers, and the bus configurations, among other things, within our substations, in our GIS. And the utility network is great for that, because we didn't even have a data model for it in our GIS before, because we never mapped it. Now, utility network has a built-in way of doing that, so we should be able to just, once we find the data, which might be the hardest part of it, to just plug it right in to a data model that already supports it well, and we're looking forward to that. And then the phase 3 would be sort of this network model management concept that I mentioned earlier, which is being able to integrate it with other systems, which again, utility network will help us with, because it's such a standardized model. It's SIM compliant. It has data fields that the other systems would need it to have in order for us to align with them.
UDC